Here's one for tomorrow's lesson. Now we've done proportions, so as we always do, the next thing is means. There's a soda machine here, and it's supposed to fill cups with 32 ounces of soda. And we're not sure if it's actually doing the job right. So what we do is we take a simple random sample of 20 sodas, and they're listed right here. And is there enough evidence to suggest that the machine is filling the cups with less than 32 ounces? Okay, well, let's get started. We need a null hypothesis and an alternative hypothesis. So let's write those down. So our null hypothesis is that the machine is working fine. Back when it was 32 ounces, it's still at 32 ounces. There's been no change. Remember, that's the nickname for null hypothesis, no change. But what we want to provide evidence for is that it is filling cups with less than 32 ounces. Remember, we're like a detective or a prosecuting attorney. Okay, now there's no alpha level stated, so we're going to go with this confidence level of 0.05. So our alpha is going to be 0.05. So our three conditions: random, normal, independent. So random, it says it right in the problem, right here, a simple random sample of 20 sodas. Independent, we can assume that this machine can dispense well over 200 sodas. And normal is a little bit harder because with this we have 20 values, but we need 30 in order to use the central limit theorem. So I'm going to put those 20 values into list 1 and make a box and whiskers plot and see if it's if there's any if it's radically skewed one way or the other, or if there's outliers. Okay, let me do that real quick. Here's what the box plot looks like. Don't forget, this is the minimum and this is the maximum. That's the middle, the median, not the average. This is quartile 1 and this is quartile 3. So on the calculator, it doesn't look like there's any problem. So we've taken care of those three conditions, and we can continue with this problem. Now I put those numbers into list 1, and I pressed stat and moved over to calculate one variable statistics, and it shows me that x bar, which is the average, is 31.835, and the standard deviation of the sample is, what is it? It is 0.478. 0.478. So we're going to use those numbers. Now, so just like we did last chapter, we need the new standard deviation for our sample. So take the standard deviation and we divide by the square root of 20. Now remember, that might seem weird that we just took the standard deviation of the sample, but remember, we're using this as an estimate for the whole population. So that's as if we had the whole population standard deviation. Now we're going to take that as an estimate and say, okay, now we're going to take that and figure out what the new standard deviation is for the sample. Okay, let's do that. Now that we have all that stuff, you can just imagine that we're probably going to do the test statistic, which is like the z-score, except for the mean. So our mean is, let's use 31.84 minus 32. Okay, that's what it should be. And we're going to divide that by the standard deviation, which is 0.1068. So this gives us this value right here, kind of like a z-score. Now don't forget that we're using a t distribution, not a z distribution, and we only have 20 values, so it's got kind of fatter tails. So anyway, the difference is we're going to go in the calculator and use normal, what is it? I'm finding it right now. Oh, TCDF, number 6. Okay, let me do that. So I put in the lower bound as -1,000, the upper bound as -1.498, and then the degrees of freedom, remember, it's always one less than what we have in the sample, just for safety's sake. Okay, we don't want to commit to anything. So the degrees of freedom is going to be 19, and what do we get for that? We get 0.075. So that's our p-value. Our p-value is going to be, what is it? 0.075. 0.075. So that tells us that it's too high. We're at a alpha level of 0.5, right? 0.05. And this says that almost 7.5% of the time we might get a sample that looks like this. Not enough evidence to reject the null hypothesis. So we fail to reject the null hypothesis. We don't say that the machine is fine and it's dispensing at an average of 32. We just say we fail to reject. Don't forget. Okay.